preparation for the 8th grade. And this section, we're going to be talking about linear equations and give you some examples of how linear equations look, what data for linear equations looks like, and how to recognize them when you see them in different forms. Linear equations are equations that define a straight line. So sometimes we're going to see a data set that gives us a straight line. For instance, I might be thinking about a person who's gone for a walk, and we're going to look at the time and the distance that they've covered. So we're going to have a table of data, and at the end of 30 minutes, the person has traveled 1 mile. At the end of 1 hour, 60 minutes, they've gone 2 miles. At the end of an hour and a half, 90 minutes, they've gone 3 miles. And at the end of 2 hours, they've gone 4 miles. And we want to graph this to take a look at what it looks like and decide, did they maintain the same pace throughout? This is a very simple example, but one that illustrates how we evaluate whether something's a linear equation. So we're going to graph distance on the vertical and time on the horizontal. And we're starting at 0, we go out to 30 minutes, then 60 minutes, then 90 minutes, and finally 120 minutes. And at the end of the first 30 minutes, they've gone 1 mile. At the end of the second 30 minutes, they've gone 2 miles. At the end of the third 30-minute period, they've gone 3 miles. And at the end of the fourth 30-minute period, and that's at 120 minutes, they've gone, that's 4 miles at 120 minutes. If I was graphing this, I'd graph it as a straight line that ends at 120 minutes. That line does not continue because that's as far as the data set went. So when you're looking at graphing data, you want to graph just the data points you're given and graph it so that it ends at the last data point. When I look at this, I can say, yes, this is a linear equation. It's an equation that draws a straight line. Now, when we're looking at this linear equation, we're going to be interested in 2 or 3 different specific pieces of information. One is going to be, what place does it cross the y-axis? We call that the y-intercept. Right? And then the second piece of information we're always going to be interested in is the slope. That is, how far up does it go for every unit that it goes over? All right, so the slope. Now, we have a specific form of linear equations that's called the slope-intercept form, where y equals mx plus b, where m is the slope and b is the y-intercept. In this example that we looked at for the person walking and the time and distance traveled, we could say that the intercept here is 0. So this is plus 0. So you don't really usually show it. And then the slope is going to be the amount that it goes up, 1 mile, for every 30 minutes. So in this, the slope would be 1 over 30. A lot of the time, we're going to be looking at an XY graph rather than a specific unit. And in those XY graphs, we're just going to look at the rise over the run. So the slope equals the rise, how far it goes up, over the run. We'll look at another example in just a moment. Now, we're looking at a new line, and it's plotted on the x and y axes. And in looking at this line, we can find certain pieces of information. The first thing we can look at is we can look at where does the line cross the y-axis. In this case, it crosses the y-axis at 2. So we can say that the b, the y-intercept, equals 2. The second thing we can look at is we can look at what's the slope of the line. How far does it go up for every unit that it goes over? In this case, it goes up 1 unit for every 2 units that it goes over. So our rise is equal to 1, and our run is equal to 2. So the slope is 1/2. If I'm going to write this as a linear equation in the slope-intercept form, which is y equals mx plus b, it's going to be y equals 1/2 x plus 2. So this is a linear equation. We have the slope and we have the y-intercept shown for us. So when you look at a linear equation written in the slope-intercept form, you can decide exactly how to graph it, because you always start by saying, oh, my y-intercept is 2, and I'm going to go up 1 for every 2 that I go over. The slope-intercept form is your friend in deciding what a linear equation looks like. You'll also note that I've got arrowheads on both sides of this line because linear equations go on forever in the XY system, and you need to show that it continues to go over by putting arrowheads on both ends of your line. Okay, on the CAASSP test, you're going to be asked questions about linear equations that involve having to select from multiple choices in some instances. And to do this, you have to extract information from the graph and then select the correct answer. So let's look at the graph we've got here. This is a graph of an airplane accelerating. And the vertical axis is its velocity in meters per second. The horizontal axis is time in minutes. We want to look at and extract 2 pieces of information from this. The first is we want to know what the slope is, because we have 4 statements, each one of which shows a slope and then gives us a piece of information that we have to interpret. So let's start off looking at the slope of this line. At the end of the first minute, our velocity is 20 meters per second. So we can say that the slope of this line is 20 meters per second for every minute, or 20 over 1. So let's write that down. And I want you to use scratch paper when you're taking the test. It makes it easier to keep track of what you're doing. So the slope is 20 to 1. And this means that each minute that goes by, the velocity is going to increase by 20 meters per second. Let's look at the second minute. We go to the second minute and we're at 40 meters per second. So we went from 20 to 40. That's an increase of 20. So let's look at the statements and decide which one is correct. The slope is 30 to 1. Well, that's not what we measured. We saw it was 20 to 1. So we can throw out 30 to 1, and we can throw out 40 to 1 because both of those are incorrect responses at the very beginning. Now we have to read further. So we have 2 where it says the slope is 20 to 1, and the velocity is increasing by 20 meters per second each minute, or 30 meters per second each minute. Well, we just went back and we looked at it and said, hey, it went up by 20 meters per second over the second minute. So we know that this is incorrect. So we can say, that's not right, and this is not right. This is the correct answer. That's how you are going to interpret data on linear equations when you're asked a multiple choice question. You have to decide which pieces of information are true and given to you. Don't just guess. Sit down and think. All right, what we need to be able to do is we need to be able to take this equation, a slope-intercept equation, and we need to be able to create a data table from it. So what we're going to do is we're going to start by drawing a column, and on the left hand is x, on the right hand is y. We're going to choose values of x. All right, so we've got values of x. We plug each number of x in, and then calculate the y. So when x is 0, 3 times 0 is 0, plus 2 is 2. When x is 1, I've got 3 times 1 is 3, plus 2 is 5. When x is 2, I've got 2 times 3 is 6, plus 2 is 8. When I've got x as 3, I've got 3 times 3 is 9, plus 2 is 11. When x is negative 1, I've got negative 1 times 3 is negative 3, plus 2 is negative 1. When x is negative 2, I've got negative 2 times 3 is negative 6, plus 2 is negative 4. And then when x is negative 3, I've got negative 3 times 3 is negative 9, plus 2 is negative 7. On the CAASSP test, they are going to give you an equation for a line. And they're going to give you data tables to select from. 4. You need to create your own data table so that you can decide which one is correct. Go ahead and do it. Take the extra 30 seconds to create a quick data table, and you will be able to immediately choose the correct data table from the 4 choices that you're presented with. All right, on the CAASSP test, you're going to be asked to be able to identify linear equations, those equations that give you a straight line. In general, everything where we have x and y, and they're not a fraction, they're not a power higher than 1, is going to be a linear equation. So we can have it arranged in different ways, but basically you can see a y and an x in all of these equations. Now, maybe you have a coefficient in front of it, a number in front of one or the other, the x or the y. That's okay. You might even have a number multiplying x plus a number. That's okay too. What you can't have, because they're not linear, they are curves, you can't have 1 over x. Doesn't work. You can't have a y or an x that's squared. And I can't have an x times an x because that's x squared. So linear equations have x and y in the first power, just no exponents, and we can have coefficients, we can have numbers added to them, but just x's and y's. If we see 1 over x or 1 over y, that's not okay, that's not a straight line. If we see a squared term, that's not a linear equation. If we see an x times an x or a y times a y, that's the same as y squared or x squared. That's not a linear equation. Think about identifying linear equations by looking at x's and y's and if there's a power or a fraction. All right. Sometimes we want to know where 2 lines cross because that point is a solution for both linear equations. So you may be presented with a line that's already drawn. In this case, I've drawn y equals 2x minus 3. So its y-intercept is at minus 3, and it goes up 2 for every 1 it goes over. So in this case, I've got this line drawn. Then you'll be presented with an equation for a line, and you have to graph that line appropriately and then figure out the point where the 2 lines cross. So I'm going to graph this one in red. Let's start off by making a data table of x and y values. So this is x and y. So when x is 0, y is 0. There was no y-intercept in this slope intercept form of the equation. When x is 1, y is negative 1. When x is negative 1, y is 1. Okay, I've got 3 points, actually 2 points to define a line, so I can graph it. When x is 0, y is 0. When x is 1, y is negative 1. And when x is negative 1, y is 0. Or y is 1. Now I can graph this and show what this looks like and find out where they cross. So this is the line for y equals negative x. And the solution point for this system of equations is at the point 1, negative 1. Whenever we have coordinate pairs of points, our x is on the left, our y is on the right. So if you're asked for this, at what point do they intersect, you would show 1, negative 1. And you could graph it by dropping a point on that line.